Okay, now guys, please remember I said that when a question says ask rapid times, all right? So you have to remember that, please. It's asking for 1/5 of 20. You can get that by saying 1/5 times 20. All right, now 20 on its own is not a fraction, so that's why I wrote it as 20/1. Okay, and then you could do your cross translation. So 1 and 1, I mean, I suppose you can cancel those out, but it will just be 1 again. Then you're going to say 5 and 20. 5 goes into both of those, right? So you're going to say, what's 5 divided by 5? 1. And what's 20 divided by 5? That is 4. Yes? Now there is the other method that I showed you as well, where you can do times and then simplify. Yeah. 4/1, yes, but 4/1 fraction is 4. Okay, so on the right is 4. So guys, here you would then say, okay, what's left? A 1 and a 4. 1 times 4 is 4, and at the bottom, 1 times 1, that's 1. So like I said, now you can write it as 4/1, but then you have to say that actually, guys, what is 4 divided by 1? That's just 4. Okay, so check, your final answer has to be that whole number. Okay, so just write 4. You can say 4/1, but then you have to go on a bit further and say that that is actually equal to 4. Okay, you won't leave your answer as 8/2, right? You'll say, what is 8 divided by 2? That's 4. All right, so you have to basically just simplify your answer. So yeah, basically that is what I did for all of these. You can just mark up until 1.8, so just do 1, 2, and 3, and then 6, 7, and 8. Let me know if you want me to talk through any of those. You want me to go through all any of my steps, guys. Every time they ask you to use a number that's not a fraction, you just put that number over 1. Is that clear to everyone? Did you do that as well? So here again, 42 is 42/1. So that you can do your cross translation. Okay. We're all done with 1.1 and 1.6. Okay, I'm moving down. Okay, you can see 1.4 and 1.9 there at the bottom. I'll move up just now. Yes, always. That is simplified. Oh, sorry. Yes, sorry. I thought you meant right in the next number. Yes, thank you for picking that up. You can divide these two numbers by 3. Yes. So there we go. That is actually 5/2. Last part. Okay, yes, guys, please, that's important. You always have to simplify it, but you don't have to write it as a mixed number. So you can leave it as an improper fraction. Okay, that's fine. 1.5 is on the board there. I got 7 for 1.5. Yes? It's fine, but remember I said if you do that and you do it incorrectly, you're going to lose them all. So rather don't do it. You're going to waste time and you would run the risk. Just leave it as an improper fraction. Yeah, there's 1.10, 1/2. So yeah, guys, here in 1.9, I used the other method where you don't cross cancel first, but where you actually just times, right? But you also could have cross canceled there already in the beginning, and you would have gotten 5/2. Any other questions? Are we all fine? And this was the last one in number 1. Hey, it went to 1.10. So we will look at 2 now, and number 2 is where you actually add it and subtract it. All right, guys, again, I just did them next to each other, so just mark in that way. The first one was easy because the denominators were already the same. So they were already both written over 7, so you could just add the numerators together. I remember when you're adding and subtracting fractions, you never add the denominators. You make them the same, and then the denominator has to stay the same. Yeah, you have to simplify them. Yes, did I not do it again somewhere? Just in general, yeah, always. For any fraction, stuff you must always simplify, yes. Guys, for 2.5, all right, you didn't have the same denominator. So 5 and 3, so you need to think of the smallest number that 5 and 3 can divide into. So we all agree that it's 15. Yes. Right, so the LCD here is 15. So you could, like we did in class, you could write that on the side if that helps. All right, the LCD is 15. So then you look at your denominator here, you say 5 times what is 15? 5 times 3. So then you do the same thing at the top. For this denominator, 3 times what is going to give you 15? 5. So you must multiply the top by 5 as well. Okay, so you then end up with 3 over 15 and 10 over 15. So you have the same denominators. You're going to keep that denominator as 15, but then you add those numerators together. Yes. So if you do a number that's bigger, I can go to your then you won't get the wrong answer, but then your answer that you're going to get, you're going to have to simplify. Okay, so you might get something, you might get like 20, and then you might simplify. Okay. 2.2, also they have the same denominator already, so you could just minus those. And here is now an example back where you have to simplify. All right, 2 over 12, can't leave it like that. 2 goes into 2 and into 12, so you have to divide both of those by 2. Right, so we find that one. So guys, it was basically just the same method all the time.
I'm so sorry. David. Sorry, ma'am. Can I speak better? Sure. Taking time today.
Okay, grade 8, 2.7. I must apologize. I actually didn't do an example like this with you, where they're giving you mixed numbers and you have to add them together. Did you guys know that you have today? I suppose you could just add those numbers together and then the fractions, but rather don't do that. That's going to complicate things. I know that's what you did in primary school, but let's try and now do a method that will work for all cases. All right, especially when you're minusing, sometimes it gets a bit tricky if you don't convert it. So first, when they've given you mixed numbers, write those as improper fractions. Then you can just add those two together. Right? So I know some of you might have just said, okay, 4 plus 2 is 6, and then you would have added the fractions together. That's okay. But going forward, let's try and use this method instead. Especially when you start working with algebra. It's going to be tricky if you don't convert into improper fractions. So guys, for 2.7, if you didn't do it like this, can you just copy this down quickly? I'll give you some time. And the same thing for 2.8, please. No, so like I said, it's not wrong, but you won't be able to do that when we're doing algebra. So I want you to practice this method as well. So guys, it was actually in 2.7 and 2.8. So just make sure that you are just copying down both of those. Sorry, that was my bad. I forgot to do an example like this in class. I don't want to say again, mixed numbers aren't wrong, it's just unnecessary. I have seen that multiple times before. Okay, any other questions on 2.7 or 2.8? You guys still busy? I'll give you some more time. Please hold up. So you remember you have to times it. So you're going to say the 7 multiplied by the 8. You always do the whole number multiplied by the number. And then we practice in that other word. So guys, 2.9 and 2.10 also had mixed numbers in. So I would like you to quickly, you can just do it underneath all of your questions, right? Because you did 3 to 3 point, was it also 10? Yes, you did question 3 to 3.10 as well. Just underneath that, can you just redo 2.9 to 2.10? Right, so 2.9, I'll write the questions down for you quickly. Just using this method that I showed you now, so that you at least have some practice in it. So 2.9, the question was -2 and 2/3 plus 4/3. Okay, just quickly, I'll give you some time to do that. And then 2.10, I also want you to do that one. It was 4 plus 2/3 minus 1 and 3/4. Just do those two on your own quickly. If you didn't, if when you did them at home, if you left them as mixed numbers. Okay, just really do them quickly. So that's -2 and 2/3. You're going to change that to an improper fraction. And this one here, 1 and 3/4, you're going to change to an improper fraction. Okay, just do those two quickly. I'll give you some time. Remember, what are you going to do with that 4, guys? 4 is not a fraction, so how do you write it as a fraction? That's one. What are you going to do with 4? Four over 1, thank you. So guys, remember that 4, don't work with the 4, work with the 4/1. Okay, just write it as 4/1 first. So you want to have all fractions so that you can use the same method across the whole question. Yeah. For this one, you're going to do that thing where you say 1 times 4 and plus 3. Right? And you probably got it. Yes. Now I'll just give you 30 seconds, then we'll mark those two. Okay, let's take a look. All right, that is what I got. Now guys, in 2.9, there's another issue here, and that's like minus. Okay. Now you're going to take the -2, right? And you actually have to, difficult to explain this. What you actually are doing, and I hope this makes sense, is you're actually calculating what that is, and then it's just a negative number. Right? What is 2 and 2/3? You would say 2 times 3 is 6, plus 2 is 8. Right? 2 and 2/3 is actually 8/3. But now we're just saying that must be negative. Negative 8/3. All right, so just check that. Some of you might have a different number here. Okay, this is actually a different type of situation. So I'm just going to make a little note here on the side. I circle that. I'm just going to say that it's almost like you're keeping the minus and the numbers separate, which is strange. We haven't really looked at that before. So we haven't seen that before. But guys, if you just have to calculate 2 and 2/3, that would just be 8/3. I think we're all fine with that. We all would be able to do that, right? But now we're just saying that that number is a negative number. Okay, it's the same as saying -5. It's not the value of 5, but it's just a negative number. Okay, so just make sure that you get to that there, please. And then this 4/3, luckily in this case, we already have the same denominator, so we can just add them. But guys, now it's -8 plus 4. Right? We need to remember our negative number work. -8 plus 4 is -4. Okay, so that is why that whole fraction is negative. You could have written it like this at first. -4/3, but remember I told you if you're getting that, you have to put that minus in front. Because what you're actually saying is a negative number divided by a positive number is a negative number. Okay, so it's fine if you wrote it like that, but you have to add another step where you just put that minus inside. Okay. 2.10, so 4, like I said, you write as 4/1. The 2/3 was already a fraction, we're going to leave that as it is for now. This one, again, is a similar thing, guys. Now we're minusing this number, all right? So you're going to say 1 times 4 is 4, plus 3 is 7, and then that would be 7/4. Right? Because it was over 4 originally. Now you're looking at your 3 denominators. We have 1 and we have 3 and we have 4. Do we agree that the smallest number that all 3 of those can divide into is 12? Yes. Right? So now you look, you can write that on the side. Remember, that is useful sometimes. Just so that you don't have to keep thinking, oh, what was the LCD again? Oh, I forgot. Okay. Better if you just write it down on the side. So now you need to ask yourself, what if I multiply 1 by to get 12? 12, right? 1 times 12 is 12. So you do the same thing at the top. 3 times what will give you 12? 4. So you do the same thing at the top. And then for the last one, 4 times 3 will give you 12. So you just multiply the top by 3 as well. So now you're going to do all of those multiplications. 4 times 12 is 48. And at the bottom, you have your denominator of 12. Yeah, now there's a plus, right? Because we're adding the next fraction. 2 times 4 is 8, and then that's over 12. And then we are subtracting. 7 times 3 is 21, and that is then also over 12. And now, guys, we need to just add and subtract the numerators, right? So we're going to say 48 plus 8. Do we agree that that's 56? 48 plus 8 is 56. And then you need to say 56 minus 21. Right, and that is 35. Okay, 35 over 12. And in this case, you couldn't simplify. So there's another number that goes into 35 and into 12. Yes? The same number, yes, when you're adding and subtracting. Yeah. And then you leave it as that number. Yeah. Yeah, you must always simplify. Yeah, so if it was 36 over 12 and you could actually do that division, your answer is going to be a So first you change the denominators and the numerators, right? Because we have to change all of these. So you change the denominators, but yes, then you add the numerators, not the denominators. Yeah.
I think because, whole number is convert that means I mean, there are improper fractions, and then you
The mixed numbers, yes.
you start to like the
Yes. Yeah. That's fine. Yeah, that's fine. We can do that. Okay, guys, 3 was just multiplication and division. So let's just mark those quickly. So 3.1, you couldn't cancel anything out, right? 2 and 5, you can't. 3 and 1, you can't either. So then you just need to multiply your numerators. So 2 times 1 is 2, and your denominators 3 times 5 is 15, and that's your final answer. In the next one, guys, I hope that you can still read what these numbers are. It was 7 over 8 and 4 over 21. So when you cross cancel, remember you look at the top of your first fraction and at the bottom in the second one. So if you have 7 and 21, both of those you can divide by 7. So 7 divided by 7 is 1, but 21 divided by 7 is 3. Okay, so I'm actually left with a 1 and a 3 over there. Then if you're looking at 4 and 8, 4 can divide into both of those. So 4 divided by 4 again is 1. And 8 divided by 4 here is 2. Now, guys, the numbers that are left, those are now the ones that you multiply. Remember? So now you're going to say at the top, 1 times 1 is just 1. And at the bottom, 2 times 3 is 6. And that is then your final answer. I'll come back up to these ones just now. For 3.3, they gave you 5 times a half. Now, that's 5 again is not a fraction. So I just put it over 1 so that it is a fraction. Okay, so that's useful with all of these fraction questions. When they've given you a whole number, you can just always write that number over 1 so that you can apply your fraction rule. Now, guys, 5 and 2, can I cancel those? No, and 1 and 1, I mean, I can, but then I'm just going to be left with 1 and 1. Okay, so you can cancel those if you want, but it's not going to change anything. So at the top, I have a 5 times 1, which is 5, and at the bottom, 1 times 2, which is 2. Okay. Same thing here, but now, guys, when you are dividing by a fraction, remember what you do? You tip and times. So you change the division symbol to a multiplication symbol, and the fraction 1 over 2, you tip and you turn into 2 over 1. So that was the second times part. At the same time, I wrote 5 as 5 over 1, just so that I again have a fraction and a fraction. So guys, again here, I can't cancel anything out, right? It's a 5 and a 1 and a 2 and a 1. So I'm just going to multiply my top. 5 times 2 is 10. And at the bottom, I have 1 times 1. All right, 10 over 1, what's that equal to? 10 divided by 1 is just 10. So your final answer, please, has to just be the number 10. Okay, not 10 over 1, just 10. Add that in to before we have that. Okay, any questions up until this point? Okay, 3.5. Again, I had a 3, which I just wrote as an over 1. So guys, you can see I literally just took a different kind of pen and I just put an over 1 there underneath the 3. You can do that as well. Okay, now here, 3 and 1, I can't cancel. 4 and 3, I can't cancel. So you're left to just multiply those and multiply those. Okay, 3 times 3 is 9, and 4 times 1 is 4. So the next one, again, I have a 3, which I just wrote as 3 over 1. But now I have to flip in times because I'm dividing, right? Guys, every time you're dividing by a fraction, you have to flip in times. So this division symbol turns into a times symbol, and 3 over 1 is going to become 1 over 3. Now, guys, if you didn't put that 3 as 3 over 1, I don't know, what do you get when you tip that? Right, you have to write it as 3 over 1. So that when you tip 3 over 1, you get 1 over 3. Okay, that's important. please add that in if you didn't add that in 2.6. So whenever they've given you a whole number, put that number over 1. Yes. Yes, so that's like 1. So you will write it as another 6. Yes, yeah. So you'll get your 3 over 12, and then you'll divide each of them by 3 in the next. Okay, 3.7 is also there, guys. Again, it's a time situation. This needed 3 times. 5 over 14, you have to turn that into 14 over 5. Right? And now we could actually cross cancel. With 2 and 5, you can't. But with 7 and 14, you could. 7 divided by 7 is 1. And 14 divided by 7 is 2. So now you're going to say, what's left at the top? 2 times 2 is 4. And at the bottom, 1 times 5 is 5. And guys, if you didn't cross cancel, right, that was the other method that I wrote down. So if you didn't cross cancel, you could have just from the start multiplied the numbers at the top together. What's 2 times 14? 28. And at the bottom, you could say 7 times 5 is 35. But now you need to check, guys, because you didn't cancel, right? Then often this is something that you have to simplify. What number goes into 28 and into 35? 7. So now you're going to have to divide each of those numbers by 7. Okay, to get to your answer 5. But guys, here, right, in your 2 options, when you're cross cancelling, I also divided by 7, right? I just did it a step above. So you're doing the same thing as here, it's fine. As long as your final answer is 4 over 5, that is important. Okay, last few questions. Now again, you might not have written these as mixed or as improper fractions, so you can just take a look there, you can copy it down if you didn't. And then 3.10 was also something that we didn't practice. Okay, so I'm going to talk through this. But guys, for 3.8, in order to tip in times, you can't have a mixed number. Right? That's important. So you need to change this first fraction to an improper fraction. So you're going to say 2 times 3 is 3 plus 1 is 7 over 3. Hang on. And now I'm not tipping times in yet. I'm just first changing these. Okay, so I'm not going to tip anything yet. I just actually need to know what that fraction is before I can tip it. Right? Does that make sense? So 1 and 1 over 6. I'm going to say 1 times 6 is 6 plus 1 is 7. And that is then over 6. Now in the next step, I'm going to change this dividing by 7 over 6 to multiplying by 6 over 7. Okay, so you have to first change your mixed numbers to improper fractions. Guys, for all of these questions, all right, sorry that I didn't do examples like that in class. Whenever you're working with fractions, adding or subtracting or multiplying or dividing, and they're giving you a mixed number, first change it to an improper fraction. David, do you want to ask something? Now for 3.8, it's fine again if you wrote it first as 2 over 1, but then you have to have your final step equals 2. The final answer there has to be 2. Do you have any questions on 3.8 or 3.9? I'm going to talk about 3.10 now. And we all finally got it. Yes. If it is a whole number, then but if it was like a 2 over 3, that's fine. But if it's a 2, then it's not. Now, guys, in 3.10, we had 3 fractions. Okay, and the first one was a mixed number. So that one, first you have to change that to an improper fraction. And guys, you actually get a mark for doing that. Right? You haven't even multiplied or divided anything, but you have 1 mark already. Just for changing that mixed number into an improper fraction. That is your first mark. Then I'm multiplying by negative 9 over 4, which I just rewrote. And now this dividing by negative a half, you need to tip and times that. So the dividing you're going to change into multiplying, and 1 over 2 you're going to change to 2 over 1. But guys, we did an example on when was it, Monday, where you did have a negative, but when you different times, you don't take that negative away. Okay, the minus will still stay. So that was me changing my mixed number into an improper fraction and different times. So guys, let's just quickly sort out the sign of this answer. A positive times a negative is what? Positive times a negative is that? Positive times a negative is a negative. So this, when I multiply these two together, I'm going to get a negative. But now I'm multiplying that by another negative. What's that? Positive. All right. So when you are actually checking the signs of these three, your answer must be positive. Okay? So that's why my answer is positive. Yeah. You can put it in brackets. Yes. Yes. Now, guys, when you have multiple fractions like this, and you might not have known this. We did when you have two fractions, you cross cancel, right? So when you have three fractions, you can also cross cancel. But you can do something like this. You can cancel a number here at the top with a number at the bottom of your last fraction. You can cancel a number here at the bottom with a number there at the top. You can cross cancel in all three fractions at the same time. Now, in this case, you didn't actually have to do that, right? You could cancel this 3 and 9, so it's 2. You would say 3 divided by 3 is 1, and 9 divided by 3 is 3. Okay, so I cancel those two. Then you could say here you have a 4 and a 2. 2 divided by 2 is 1, and 4 divided by 2 is 2. Okay, and then there was nothing else that you could cancel out after that. Yeah. Yes, yeah. So guys, if this was, that's a good example. If this 7 was an 8, can we quickly visualize that? Say that was an 8, right? And you cancel these two out. You're left with a 2 here. If that was an 8, you could take that 2 and cancel it with an 8 over there. Okay, so when you can cancel in multiple directions. I'll see if I can find some more examples like that so that you can see how that would work. All right, now we're looking at all the numbers that are left. I have a 7 times 3 times 1. That's 21, right? 7 times 3 is 21. At the bottom, I have 1 times 2 times 1, which is just 2. Yeah, so the answer there is 21. Any questions? Okay, we are moving on to something new today, but we will keep practicing these, all right? But we have a couple of loose ends to tie up, just in terms of fractions. There's different types of questions that they can ask you. So the first one is just comparing fractions. Some of you might know how to do this, some of you might not. You need to know it for your test. So we are just going to do 2 examples. Yes.
My mom made a mistake and I actually found that.
Oh, really? Okay, that's fine. No, it's on everything we found earlier. So I'll tell you on Friday exactly what to do. Now I'll give you a list. Yes. Yes, construction, what in there, yeah. The test is on everything you've done this year. But I'm going to give you a more detailed list. There should be a list going up on Google Classroom today, actually. That list is supposed to go up. So then you can go check on the gray Google Classroom. Yeah. We're still waiting for the mark sheets from the department, so we don't know what the waiting is week. Yeah, we'll have to wait for the WPE, who knows when they're going to say that, but once I know, I'll tell you that. Okay, guys, which fraction is bigger, 5 over 11 or 1 over 2? Now, I'm sure you can do the science fiction, all right? So let's not go into that now. If you can do it by inspection, it's fine, but you won't always be able to. So I'm going to show you a method now that you can always use, no matter what the fractions are, that will always work. Now, guys, like we did when we added and subtracted, right? We could only add and subtract fractions if they have the same denominator. The same thing is true here. We can actually only complete fractions if they have the same denominator, right? At the moment, my one denominator is 11. My other denominator is 2. So what I'm going to do is I'm going to write both of these fractions with the same denominator. Then it will be very clear which one is bigger. Okay, so we're actually going to find the LCD. That's the first step. Okay, so step one. Write both fractions over the same denominator. And that denominator is going to be the LCD. Okay, so we've already practiced finding LCDs a little bit. We're going to practice that again now. So let's think, the smallest number that 11 and 2 can divide into. Yes, 22. We agree with that. The LCD here is 22. Okay, so the LCD in this case is 22. Just going to go over to this graph with blue pen. So 5 over 11, guys, you have to write them separately now. Okay, 5 over 11. What does I multiply 11 by? Turn it into 22, you say that? 2. So I'm going to multiply the bottom by 2 because I want it to be 22, right? Then I'm going to do the same thing at the top. Now you're going to work that out, guys. 5 times 2 is 10. And 11 times 2 is 22. That's the one fraction. We need to do it with the other one as well. Okay. The other one was 1 over 2. What does I multiply this denominator by? This 2 to turn it into 22. Alex? 11. Thank you. Can put the last one, please? And then I will do the same thing at the top. 11 and 12. So just what we did now when we added and subtracted them. Okay. So now I'm getting 1 times 11 is 11 over 2 times 11 is 22. Now guys, if you're looking at these ones, I think it's quite obvious that 11 is bigger than 10. Right? 11 over 22 is bigger than 10 over 22. So you're going to look at the numerators. Okay. So that's going to be step 2. Compare the numerators, the numbers at the top. And that will then help you to decide which one is bigger. Sometimes they're going to ask which one is smaller. All right, then you're obviously going to look for the smaller number of the two. Now, guys, I want us to write this in proper mathematical notation. We have looked at that symbol once before, but I'm going to write it now again. Okay, 5 over 11 is 10 over 22, and 1 over 2 is 11 over 22. Again, which one is bigger here? The second one, hey, the 11 over 22. I'm going to take a highlighter and just circle that one. That one is bigger. Okay, so we circle the one that's bigger. But guys, be a bit thinking about what you actually write. In the answer, they don't want you to write 11 over 22 is bigger. They want you to write the fraction that they gave you. Okay, so they actually want you to write that a half is bigger than 5 over 11. Okay, so we're not going to write this is bigger than this. We're going to write the original fraction, the one that they gave in the question. Okay, we're going to write a half is bigger than, do we remember that symbol? We looked at it a while ago. Greater than, bigger than 5 over 11. Okay, so the bigger part of that symbol is facing towards the bigger number. Or it also would have been fine if you just wrote 1 over 2 is bigger. Or if you just wrote 1 over 2, right? The question is just asking which fraction is bigger. So it's fine if you just say a half as your answer. But I do want us to work with this symbol just so that we get used to it. Okay, so that when we eventually use it later on, we're not like weird headlights. We know what's going on. But guys, it's fine if you just say a half is bigger. Okay, I'm going to let you do one on your own quickly. Number 2. 5/6 or 3/4. So you need to compare those two and you need to decide which one of those two is bigger. So I'm going to follow the same steps that I wrote down here. Yes. Oh, yes, sure. You're going to use the same steps, but the LCD now is not going to be 22. Hey, you need to look at these numbers and figure out what, no, don't say, figure out what the smallest number is that 6 and 4 can go into. Don't chart it out. I want everyone to do it on their own, please. And then you're going to compare them. Okay, so find the answer there quickly on your own. Everyone do it, please. You don't have to write down step 1, right? Both factors. You're just doing the actual wording. Please. Okay, do we have an answer there, guys? Here we go. So you're going to say 5/6. Do we agree that the LCD is 12, guys? With 6 and 4. Okay, so 5/6. You're going to times that by 2 because 6 times 2 will give you 12. You're going to do the same thing at the top. 4 times 3 is 12. So you do the same thing at the top there. And now you're going to compare your numerators. 10/12 and 9/12. Right? 10 is bigger than 9, guys. So this one is bigger. We can again just circle it using the highlighter like we did in the previous question. 10/12, that is the bigger one. So it's fine if you just say that 5/6 is bigger. Perfect, full marks. All right, it's fine also if you use the symbol. So you write the bigger one first, and then you have your bigger than, greater than symbol, and then the smaller one. Sometimes, guys, they actually give you 2 fractions and they leave the middle bit open, right? So they say you have to put in the symbol. So then you'll have to decide if this one is bigger, you must put in that symbol. If that one is bigger, you must turn it around. Okay, but we'll do some examples of that later. Are we okay with this, guys? Do you understand what you need to do here? You need to get the denominators the same and then you compare the numerators. Okay, right, converting fractions to decimals and percentages, that is the next thing that we need to do. Might not go through all of it today, and you'll have to finish off tomorrow. Oh, that's what happens when you use it as a call, eh? Are you okay? Are you hurt? Thank you, Alex, for your heroic act. Okay. Okay, guys, we're just gonna do a bunch of examples. Okay, we're gonna see how long or how far we get. So the first one, convert 2/5 to a decimal. And guys, obviously all of this without a calculator, right? So you can't now just type that into the calculator and see what comes up. All right, you need to be able to do all of these things without using the calculator, remember? Does anyone know what to do?
We have to get the denominator 10.
Okay, you have to always get the denominator to a 10 or 100 or 1,000, whatever the easiest one really is to do, okay? So we're going to get 5 to 10. So let's write that on the side. Return I'm just going to write denom for denominator because we've written denominator about 1,000,000 times now. I'm tired of writing it out. Turn the denominator into 10. Or another multiple of 10. We'll see in another example. Right, so it always has to be a 1 and then however many numbers of zeros you have there. So you're going to have 2/5. So guys, how do you turn 5 into 10? What must you do? Times by 2, then you must do again the same thing at the top. So what is that? 2 times 2 is 4 over 5 times 2 is 10. Now guys, this 10, right, the denominator that we have now, we see that it has 1 0. Okay, so this denominator, 1, let me rather say it has 1 0, because otherwise you might think I'm just saying that that's a 1 and a 0. I mean that it has 1 0, so that means that there has to be 1 digit after the comma. Okay, I'll show you now what that means. Therefore, 1 digit, 1 number, 1 digit, right, after the comma. And the digit that you're going to write after the comma is the number at the top. What's going to come before the comma? What do you guys think? A 0. Okay, so we're going to say 0, comma. There's 1 0 in my denominator, so there must be 1 digit after the comma, and that digit is going to be the numerator. So 0, comma 4. So 4/10 is 0, comma 4. Yes. So this is basically saying that this is 4 tenths. So if you divided 1 into 10 parts, this fraction is 4 of those parts. So that's what we're saying. We're then saying that it is 0, comma 4. Basically 4 parts of 1. Yes. Yeah, then they won't really give you that one to do not at grade 8. Okay, you will always be able to either write it over 10 or 100 or 1,000. Okay, let's do another one, guys. Number 2. Convert 13/20 to a decimal. Now guys, when you're doing these questions, you're never going to divide. Okay, so you might think now, okay, I must make that denominator, I must make 10. Right, but in order to turn that into a 10, you're going to have to divide by 2. You're never going to divide in these questions. You're always going to times, yeah? You can write it down if you want to. You don't always have to answer every question out loud. So here we're going to turn the denominator. Now guys, if you can't turn the denominator into 10 by multiplying, you're going to have to try and convert it or turn it to 100. Okay, it's always a 1 with a 0 or then a 1 with 2 zeros. So we're going to turn this denominator into 100 if we can. Can I? If the denominator is 20, can I turn 20 into 100? Yes. What does I multiply by? 5. I'm going to multiply the top by 5 and the bottom by 5. Now you need to be able to do this in your head. That's 13 times 5. 65, hey? 13 times 5. We're going to say 10 times 5 is 50. Yes? And then 3 times 5 is 15. What's 50 plus 15? 65, yes. All right, 50 plus 15. 50 plus 15 is 65 over 100. Now, guys, this denominator now has 2 zeros. Therefore, there are going to be 2 digits after the comma. However many zeros you have in your denominator, that is how many digits you have to have after your 0, comma, whatever. Okay, so 2 digits after comma. And those 2 digits are going to be 6, 5. Okay, so my decimal is going to be 0, 6, 5. So it's always a numerator that you put in your actual decimal. All right, as soon as you've written it over 10 or 100 or something. Yes. 0, 5. Yes, I'm going to do an example like that now. Number 3, please. Say again? I just want to do one with you quickly that's different, but yes, then I will give you some to do on your own. Okay, we now want to just convert 1 over 20 to a decimal. It's similar to the previous one. There's just something different here that I want you to see. Now again, guys, the denominator is 20. Can I turn that into a 10 by multiplying? No, so I need to turn it into 100. So turn the denom into 100. So you're going to have your 1 over 20, and we've done something similar already. 20 times 5 is going to give you 100. So that is what you're putting at the top and the bottom. So you're going to end up with 1 times 5 is 5, and 20 times 5 is 100. So again, we have 2 zeros in the denominator. So we're supposed to have 2 digits after the comma. But now, guys, our numerator only has 1 digit. All right? So now, because we only have 1 digit, we have to put 2 digits down. Yes? Yes, it's going to be 0, 0, 5. You put in a 0 in front of that 5, almost as like a placeholder. Can I put it as 0, 5, 0? Is that the same? 0, 5, 0 is actually a half, okay? It's 5 over 100 a half. No. All right. So, guys, if you have, I'm just going to add here, has 2 zeros again. Therefore, 2 digits after comma. And guys, obviously you're not going to have to write this each time you do one of these questions. Okay, I'm just making notes while we're doing the example so that when you're doing some on your own, you can look back and you can see what you wrote. So now this 0 there, just make an arrow pointing to that 0. There's something. And I will just giving you some questions with the chapter from the answer series. They don't really have, oh, wait. It's all right. They don't really have questions. Just like this, we'll try and stop. Yes? Yeah, so if I can get go ahead and stop this one. Do it now. Because I'm scared something's gonna get. Okay. Back over the start of it. We're gonna walk to the start room, just opposite the start room, just walk a little bit past. There is a door to your left. Alright, there's a lot of white furniture and stuff back there, but that's how you get there, right? Back to the start room, a little bit further to your left.